Hello, Mr. Geiselhardt here, and we're going to solve systems of equations today. First thing we're going to do is we're going to solve them by graphing, and then we're going to solve them algebraically. So, to solve them by graphing, what you're going to start off seeing is a grid. Now, you're not going to have to graph it the way we normally do with pencil and paper. You're going to graph it on the app or on the website that we have here. So, the way you're going to do that is the first thing I want to do is I want to point out that down here at the very bottom, you see my little finger around here, there's two different boxes here. The first one is to draw a line, the second one is to draw a point. So if we look at the directions, first graph each line, then click on the black dot below the graph and place it on the point of intersection. So the first thing I have to do is actually draw on the two lines. Well, we have y equals negative x plus 4, so that's in slope-intercept form. So all I need to do is put in 2 points that are on that line. I'm going to start with my y-intercept. So in this equation, my y-intercept is at the point 0, 4, and my slope is going to equal negative 1, which means I go, if we do rise over run, negative 1 is just down 1 because it's negative, and to the right 1. So that's how I'm going to do that. So if we go back to here, we will see that if we start at the point 0, 4, that's right there, then the second point is I'm just going to go down 1 and to the right 1, which is right there. So that plots my first line. So now I'm going to plot my second line. Well, to do that, all I need to do is find the slope and the y-intercept for this one. So again, if we start with the y-intercept, that's just going to be at the point 0, 1, except now my slope is equal to 2, which means I go up 2 and over 1. So I'm going to go ahead and start at the point 0, 1, and I'm going to go up 2 and over 1, which is right there. So now it's pretty clear to see that the point where they intersect is at the point 1, 3, and we'll write that as an ordered pair, making sure you put parentheses around it and a comma in between. And then it's asking us to make sure we put the point on there. So we need to come down here and now highlight. So see how I highlighted the dot point rather than that one. And then I'm just going to put that right there. Whoops, hang on a second. I'm going to put the dot right there, and then it puts the dot in for me. Now, if I want to check this, I submit my question, and I got it correct. Okay? So that's how you do those by graphing. The next one we're going to do is we're going to solve this algebraically. Now, there's 3 different ways that we solve algebraically. One is by the elimination method, one is by the equal values method, and one is by the substitution method. The first one here is going to be the equal values method. We say that because the y's are the same. In other words, it's y equals something and y equals something. So equal values just means now I'm going to take the x terms and set those equal to each other. So I'm going to have negative 5x minus 9 equals 3x plus 7. So to solve this, I have to combine my like terms. So I'm going to start off by adding 9 to both sides, and then I'm going to subtract 3x from both sides. When I do that, my 9's will cancel out here, leaving me a negative 8x. My 3x's cancel out here, so then I'm going to be left with 16. Divide by negative 8, and I get that x is equal to a negative 2. So we know that x is negative 2. Now in this particular problem, notice that it has the ordered pair already sitting out for you here, where it has a separate blank for x and a separate blank for y. So all you need to do is fill that in. There will be questions, however, later on where you're going to have to put in the entire ordered pair on your own. So now to find y, we only found x. To find y, I need to substitute negative 2 in place of x over here. It doesn't matter whether I use the top equation or the bottom equation. So I'm going to just go ahead and use the top one. So we have y equals negative 5. Now instead of x, I'm going to put in negative 2 and then minus 9. So negative 5 times negative 2 is a positive 10, minus 9, so that will equal 1. So my y value is just 1. And we can check our answers because I have them here. That's negative 2 and that's 1. So we got those correct. So let's take a look at the next type of question. The next type of question is solving using elimination. Now, I'm going to do the second one, and here it's called the addition method, but I call it the elimination method. It really means that we want to get rid of one variable or the other, either the x's or the y's. So in this first one, it looks like it's easier for me to get rid of my y's, and that's because I only have to multiply the top equation by some number. Now, there might be times when you have to multiply the top equation by one number, the bottom equation by another number to get one of the variables to cancel out, either the x's or the y's. So in this case, what I'm going to do is I'm going to multiply this top number here, our top equation here rather, by -8. When I do that, I'm going to end up with on the top a positive 56x, because -8 times -7 is a positive 56, minus 8y, because -8 times -y, I'm sorry, -8 times y is -8y, is equal to -8 times 56, which is going to give me a -448. So now the bottom equation didn't change at all, so that's still just -3x plus 8y is equal to 77. So here's where the elimination or the addition comes in. What I'm going to do is I'm just going to combine. I'm not going to say add because sometimes you subtract, so I'm just going to combine these two. So 56x minus 3x will give me 53x. The -8x, positive 8x cancel out, and then the -448 minus 70, plus 77 is equal to a -371. Then when you divide that by 53 and divide that by 53, you get that x is equal to a -7. And if we want, we can check that answer by just putting in -7, and that's what it's going to be. So we have -7 here. Now that I know that's -7, I can find y by substituting -7 in for x. So again, I'm just going to choose the top equation. So I have -7 times -7 plus y is equal to 56. Well, -7 times -7 is a positive 49 plus y is equal to 56. So if I subtract 49 and subtract 49, that means that y is going to equal 7. So my x is 7, and then my y is also, or my x is -7, and then my y is 7. Okay, so those two methods are the elimination method and the equal values. So we got one more method to do, and that is the substitution method. So to do the substitution method, we do that when we have y equal to something, or if it was just x equal to something. So notice I have the y by itself right here. That's where we use substitution. So what I'm going to do is I'm just going to take whatever y equals and substitute that in for y there. So we'll have something that looks like this. X minus, and then we have 3 times 2x minus 3 is equal to 24. So I have to take this -3 and I distribute that. So I have -3 times a positive 2x, so that'll be x minus 6x. And I have a -3 times a -3, which will give me plus 9, is equal to 24. So now I need to combine my like terms. X and -6x gives me -5x plus 9 equals 24. So if I subtract 9, I get -5x is equal to 15, divide by -5, and I get that x is equal to a -3. So now here I'm asking you to actually write it as an ordered pair rather than entering your x and y in separately. So my ordered pair is going to be -3, and then of course I have to go back and find y. So I'm just going to take -3 and put it back in for x there. So y equals 2 times -3 minus 3. So that'll be 2 times -3 is -6 minus 3 is equal to -9. So my coordinates should be, or my ordered pair should be, -3, -9. And that's what that is. So those are how you solve these systems of equations. This is Mr. Geiselhart, and I hope that was helpful.